All right, so day 4 is a little bit different. We've been concentrating on creating graphs based on videos or stories that we are given. Today what we're going to do is we're going to look at analyzing a graph. What can I tell from, what kind of information can I get from a graph? All right, so let's look at this. I want you to look at this graph, and I want you to pay attention to everything. The title, the numbers, what the graph actually looks like. And so the title of the graph is Water Consumption in a Typical School Day. So I want you to think about what purposes is water used at school. There's a little bit of water that would be used for cooking. The primary use of water in school would be our bathroom usage. You know, think about how many times you go to the bathroom a day. Multiply that times the number of students we have in the school building. So really the primary use is bathroom use, but you could have water fountains and, like I said, some cooking. What do you think the numbers along the horizontal axis represent? Horizontal, right here. If you will look at how they're written, it probably represents the time of day. What might the numbers along the vertical axis represent? And do we have any indication of the units being used? So maybe this is the amount of water that's used. There's no real knowing just yet what that is. And we don't know how it's being used in units. Are they looking at gallons? Are they looking at, millimeters, liters? How are they measuring? But we can probably assume that since the title of the chart is water consumption, that they're probably looking at, in some way, relating to the volume of water. So I want you to look at this graph, and it kind of stays the same, but then there's a spike. And then there's the same, and there's a spike. And this, what do you think those spikes might represent? Maybe they represent students using the bathroom in between class periods. You think about it, when do you try to go to the restroom? The majority of us try to go to the restroom in between classes. So maybe the bell has rang and students are using the bathroom. And now we're in class period. And then the bell rang again and now we're in the class period. So maybe that's what those represent. So those smaller spikes here could possibly be when the students are in the classroom. All right, so now let's think about this. A regular school day is from 8 to 3:05, 3:15, depending on where you're at and depending on what grade you're in. But we go from 8 to about 3:15. So then after school activities are about 3:15 to 5:30, depending on what kind of practices you're having. So let's see if we can see these features in the graph. All right. So we start school about 8 o'clock, which is right around here. Do you see a spike there? Maybe kids are going to the restroom before school starts. All right? And we said that our typical would be class and then a spike. Do those stop about 3:15? Well, guys, if you'll notice, our time is done in military time. So 12 o'clock, so 1 o'clock would be 13, 14, so we're looking at 1,500 hours, so 15:15. All right, look at what happens here. Our big, huge spike after that is probably the kids going to the bathroom before getting on the bus. And then here? There's not a whole lot of stuff going on. You've got a little bit of a spike here, and it might be getting, water for the ball team or something like that. But there's not a whole lot going on. So we're able to see those features in our graph. Is it possible to deduce the time of lunch at this school? In other words, is there a way for me to predict what time I think lunch is during this school? Well, you think about our schools. Our school has lunch in different shifts. We have elementary shift, we have a middle school shift, and we have a high school shift. All right, so we do have, 3 shifts, and really, that might explain some of these bigger peaks, but it's kind of hard to figure out exactly when lunch would be. All right, so how does one actually measure the amount of water flowing? Now, when we talked about what these numbers could represent, we said it may be the number of gallons of water used, or we might be looking at the volume of water used. What does that mean? What does it mean, used water? Okay, I want you to think about used water. Because really, is water ever, when we think about something being used, we think about it can't be, it disappears, it's gone. But does water actually go away? So, how do we actually measure the amount of water flowing through the pipes? Because when we think about used water, we're thinking about the water that drains through the pipes and leaves the school building. Okay, that's what we're talking about. The water that actually leaves the pipe, or goes through the pipes and leaves the building. So how would we measure that amount flowing through the pipes precisely at 10 o'clock a.m.? Well, let's go to 10 o'clock a.m., and I don't have an exact 10 o'clock, but we're going to say it's probably somewhere around in here. And it says that 80. Well, what does 80 units of water leaving the school at 10 o'clock mean? All right? So what we need to think about is that 80 units of water must take some period of time to flow out through the pipes. 80 units of water does not directly leave the school building immediately. It's flowing through pipes. It's taking some time. Okay? So, if you want to think about this, let's think about this in terms of you guys. Think about the bell at the end of class, which I know it's been a while since we've been in class, but think about the bell for a moment. When the bell rings, you have to get up, you have to get your stuff together, and you begin to walk out of the classroom. You are flowing through the classroom door. So if there are 25 students in that class, would I say that a volume of 25 students is flowing through the door right at that instant? I'm not going to say a volume of 25 students because it's not happening all at one time. You can't all 25 leave the room at the exact same time. You have to space it. So instead, we would say a flow of 25 students over a short period of time. So now thinking about that, let's think about that 80 at the 10 o'clock mark. All right? We can think about that. We can say that 80 units of water were flowing through the pipes at that time but not 80 units of water did not leave right at 10 o'clock. All right, now I'm going to give you some more information. The researchers who collected this data watched the school's water meter during a 12-hour period. The meter shows the total amount of water in gallons that has left the school since the time the meter was last set to 0. Since the researchers did not know when this resetting last occurred, they decided at each minute mark during the day to measure how much meter reading increased over the next minute of time. Thus, the value 80 at the 10 o'clock a.m. mark on the graph means that 80 gallons of water flowed through the meter and it left the school during the period from 10 a.m. to 10:01 a.m. All right? So within 1 minute, 80 gallons or 80 units of water left the building. So, what are the units for the numbers on the vertical axis? Since we're dealing with water, we're going to assume that these are gallons. All right, we're going to assume that we are dealing with gallons per minute. All right, and we're going to put that per minute. All right, so let's look at exercise 1. It says the bulk of water usage is due to the flushing of toilets. Each flush uses 2.5 gallons of water. Sampson estimates that 2% of the school population uses the bathroom between 10 a.m. and 10:01 a.m., right before homeroom. What is a good estimate of the population of the school? All right, so what do we know about 10 o'clock a.m.? We know that at 10 o'clock a.m., there are approximately 80 gallons of water being used in that minute. All right, this is what we know. We know there are approximately 80 gallons used from 10 o'clock to 10:01. All right, so it says that each flush uses 2.5 gallons of water. So I want to know how many flushes, because they want to know how many students are in that school building. So if I know that 2% of the school population uses the bathroom during this time that 80 gallons are being used, I want to know how many students are using the bathroom at that time. Now, let's think about this. Each flush is 2.5 gallons. Most of the time, we only flush one time. Okay? So we're going to go with one flush per student. So I have to divide 80 gallons by 2.5 gallons to figure out how many flushes. All right, so 80 divided by 2.5 would give me 32 flushes. So I know there are 32 flushes happening from 10 o'clock to 10:01 a.m. Now, once again, I said we're assuming that each student only flushes once. We can say that that means there are 32 students in the bathroom during this time. Alright, so since we know that this is 2% of the population, we can figure out how many students there are in the school building. Guys, percentages, that's 100% to figure out how many students are in that classroom. Okay? So what I have to think about is I have to think about 2% being 1/50th of the population. That means I'm taking that 100% and I'm dividing it up into 50 different sections. And that 2% is 1/50th of the school population. So, if this is 1/50th of the school population, I can take and multiply 32 times 50, and that would give me 1,600 students in the school building. Okay? So there would be 1,600 students in the school building. Samson then wonders this: if everyone at the school flushed the toilet at the same time, how much water would go down the drain if the water pressure of the system allowed it? Are we able to find an answer for Samson? Okay, so we have figured out now that there are 1,600 students in the building. The last question, we're working off of that last question, told us that each flush was 2.5 gallons of water. So if every one of these students flushed the toilet at the exact same time, which that would be really hard, that's a lot of toilets at the same time, but if all 1,600 students flushed the toilet at the exact same time, could I figure out how much water would leave the building? Yes, I could. Because we said each flush is 2.5 gallons. All right? So when I multiply that out, I figure out that we would have 4,000 gallons of water leave the building at the exact same time. All right, so let's look at this. Estimation. Can you make a guess as to how many toilets are in the school? Well, if there's 80 gallons of water being used at that minute, I was thinking for some reason that it told us a little bit there. Can we estimate how many toilets there are? Well, I'm going to give you an estimate of what I think is in the school building. And I'm going to give you that I think there are 80 toilets in that school. The reason I'm doing this is I'm going to go ahead and give you this because we need this number. And your answer may be different than mine. So I'm going to give you an answer for this one. That way everybody has the same answer. So it says make a guess as to how many students are in the school and what percentage of students might be using the bathroom at break times between classes, just before the start of school and just after the end of school. Are there enough toilets for the count of students wishing to use them? All right. Well, we've already figured out how many students are in the school. There are 1,600 students in the school. Let's think about this. Going back and looking at our chart, or our graph, looking at our graph, it wants to know about how many students are using the bathroom during breaks. Well, if we've got gallons at one point going out during a break. We've got 100 gallons going out during a break. 100 gallons going out again during a break. Some of our big spikes here. Then we've got several students that are using the restroom. All right. So let's think about this. And guys, once again, this is just an estimation exercise. We are just using estimates. We're not looking at exact numbers. But we've got several students using the bathroom at this time. We said that 32 students were using at one break. So if you've got 32 students using the bathroom during a break, and let's say there are 1, 2, 3, 4, 5, 6, 7, 8 breaks. All right. Then that is 256 students. So I've got 32 students. And I'm kind of working through this because even though we're estimating, I want you to understand where I got this. So we've got 32 students, give or take, during breaks. And there are about 8 breaks, which would give me 256 students. All right, so that's 256 students that are using the bathroom during those breaks. Now, if it's 256 students out of 1,600 students, then I'm going to divide, and that gives me about 0.16, which is about 16%. So we're going to say around 16% of the students are using the bathroom during these times. Okay? Now it says, using the previous 2 considerations, estimate the number of students using the bathroom during the peak minute of each break. Guys, we can already say that we've kind of talked about that. So if you've got 256 students using the bathroom during a break, maybe only 1/4 of them at any 1 minute. So we're going to say 256 divided by 1/4, or divided by 4, would be about 64 students at any 1 minute. All right, so we said there were 256 students, and maybe 1/4 is using the bathroom at 1 minute. Because not all 256 students are using the bathroom. Remember, we're counting all breaks over the course of the day. So we'll say maybe 1/4 is using at 1 minute. Okay? So I'm going to divide 256 by 4, and that's going to give me approximately 64 students at one time. Assuming each flush uses 2.5 gallons of water, estimate the amount of water being used during the peak minute of each break. All right, so we said 64 students, and they are using 2.5 gallons of water. So that would be 160 gallons of water during that peak moment. Okay. What time of day do these breaks occur? If the school schedule varies, consider today's schedule. So looking at these, going back to our graph for a moment, you can see that one peak would occur, what, about 9 o'clock? Well, the first one is going to be about 8 o'clock. So about 8 o'clock.